Thank you, Michael. Thank you, Greg. That was really an important lecture. Partnerships are super important.
That's right. Okay, Linda, and now we continue with Michael Leditzky, our COO Global. Works in our Rosenheim office and technology center in Germany. You know, Linda, he has been working in SolidCAM GmbH for the last 11 years, with the last 4 months also as SolidCAM COO Global. So we decided to be the providers of additive manufacturing for our SolidCAM customers. Emil and Michael launched SolidCAM Additive GmbH. Michael will let us know about this new and exciting field.
Natalie, you know, the manufacturing world is advancing in huge strides, and SolidCAM always tries to stay on top of things. Our SolidCAM customers will eventually introduce 3D printing to complement their CNC machining. So we will offer them an excellent 3D printing solution provided by their longtime customer CAM supplier, SolidCAM.
Exactly. You know, Emil checked all available 3D printing companies for metal and carbon composites, and he chose Desktop Metal as our partner for the additive manufacturing venture. Michael, the stage is yours.
Hi everybody out there. My name is Michael Leditzky and I'm the CEO of SolidCAM. Today, I would like to talk about additive manufacturing because it's part of the future in the machine chips. So let's get started. And I would like to start this whole presentation with a question to all of you. So do you think that additive manufacturing is going to replace CNC machining in the future? The answer I will give you at the end of this presentation. There are 5 big industries where 3D printing has become indispensable, starting, of course, with aerospace, then with medical, transportation, energy, and at the end, consumer products. So probably all of us had something 3D printed in his hands already. For example, in the transportation segment, airplanes, parts for airplanes are already 3D printed. The same in the consumer products market, and also medical devices are already printed, which is, I think, really interesting. So let's talk about the different materials that can be printed today, starting with plastics. Plastics, you know, ABS, PLA, PETG, probably all the materials you guys use at home with a small 3D printer, like a do-it-yourself kit or something like this. But they are major, more advanced materials like carbon fiber and also fiberglass. Going to the second point, I would like to talk about metal. And yes, metal is printed today, and it's a really easy process. We can print titanium, stainless steel, aluminum, tungsten, whatever, name it. And there will be a lot more materials are going to be added soon in this whole process. Then, of course, ceramics can be printed. Then we can print wood. And yes, it's true. Wood is printable those days. Of course, there is paper, wax, resins, gypsum, and also cells. I mean, even they printed organs. Most important, it's also possible to print chocolate. So also fruit gums and general food can be printed. But today, obviously, we are going to focus on materials that are used in the industry we are in. It's plastics and metal. On the left side, you can see plastics, an example of printed plastic parts, especially carbon fiber parts. What you can see here in the middle is, for example, a crank for a bike, for a bicycle. So you really get the feeling that those materials are really strong, sturdy, and you cannot break them easily. The X-shaped thing you see over there is the base plate for a drone, for a quadrocopter. Talking about metal, it gets even more interesting. What we see, the first part here in the left corner, is a heat exchanger. So it's distributing heat through inner channels. And to be honest, to machine a part like this is not easy. You need the part to split the part in 3 or 4 parts and machine the inner channels. And the same applies to the copper part you can see at the right bottom corner. It is a heat exchanger, for it is actually built on a rod. And there are inner channels, so water is circling through it, and also no way to machine it in a conventional way like we all know it. Of course, you can see an impeller as well. So you can actually save a lot of roughing time because the parts has been printed previously. But all the machinists out there are going to ask me, no, but Michael, wait a minute, isn't 3D printing slow? Or the next question would be, isn't it more expensive than conventional machining? How about the strength, density, the surface quality, and above all, the accuracy of the part? So those questions I would like to answer during the next slides. And the first question was, isn't metal printing slow? We see here a laser sinter process, and I'm going to start the video now. So there is a fine bed of metal powder, and there is a high capacity laser who is melting this powder exactly at the position where the contour of the part is. And now we see that there is another layer of metal powder is going to be put on the first layer, which has already been sintered. And this happens again and again and again, thousands of times until the part is finally done. So there is the second layer. So then we can see the laser again. And as I mentioned, it's going to repeat over and over again. So isn't metal printing slow? Yes, it is slow, but not anymore. There are technologies out there that are going to speed up this process tremendously. And this is where I would like to introduce SolidCAM additive manufacturing. And I'm actually really proud to introduce it to all of you. So what we're going to do now is to combine the strengths that we have in the CAM industry with a really famous reseller and manufacturer of 3D printers, which is called Desktop Metal. And I want to add a few more things about Desktop Metal. The CEO of Desktop Metal is Rick Fulop, and on the left side of the picture, you can see the start of this relationship happening last year at the Formnext, which is of course our CEO, Dr. Emil Tomek, and Rick Fulop. The headquarters is in Burlington, Massachusetts, and as I mentioned earlier, they are inventing and manufacturing those 3D printers. And they claim that they exist to make 3D printing accessible for engineers, designers, and manufacturers. And you know, it is a good thing that our customers are exactly the targeted group of those 3D printers. So let's talk about this special process that I mentioned earlier. It's called binder jetting, and this is exactly the technology that makes the slow metal printing that we have seen previously faster. And it's not just faster, it is a lot faster, it is enormous. So we start with also fine metal powder. We are going to print it, then there is a debinding where we get rid of all the excess material, and then there is sintering. And what we have seen earlier is there was sintering directly on the 3D printer. And now there is the big change. We're taking out the parts out of the 3D printer, put them in batches in the sintering oven, so the next part can be printed simultaneously at the printer. So it is called a batch process, and this allows you that the 3D printer is working all the time, producing new parts, and simultaneously the sintering furnace is going to sinter the parts where they need to be sintered. What we have now in our technology center in Schramberg in Germany is a so-called Desktop Metal Studio system, and it's the first metal printing system that is, I would say, office-friendly. So you can place it inside your office. On the left side, you can see the actual printer. It's a standard printer like you actually know it from home, but those printers are able to print metal. On the right side, you can see the furnace. It's also pretty small. You can fit it through a door. And this shows that this whole technology has reached a point where it's really reusable and easy to usable out there. Example parts we see here are some parts for engines, impellers, heat exchangers, some cloths for clamping, for example, and also jewelry can be printed in this printer. There is a nice video I would like to show because it really indicates how easy this process actually is. Enjoy. So I want to repeat, it is the easiest possible process you can have, and especially, for example, for educational institutes. For spare parts, this printer is meant to produce metal parts, not in big batches, just one part at a time, and you're going to sinter it, and you have the full metal part ready at your office. Next, there is the more advanced system, which is the desktop metal shop system. And talking about the shop system, we're talking about a printer that can actually replace a whole CNC machine, because those printers are meant to print big batches, thousands of parts, 100,000 of parts a year. And on the right side, you can see how awesome the surface quality actually is. And there is another interesting video which showcases the process of binder jetting and the desktop metal shop system in the best possible way.
You are now in the shop lab. The shop lab is designed to be a mini factory to continuously exercise the shop system, printing hundreds of parts a day for ourselves and for our customers. So the shop system is the first metal 3D printer designed specifically for machine shops, allowing shops to enter into additive metal manufacturing like never before. The shop system is a single-pass, high-resolution metal binder jetting system at a price point that has never been achieved before. The shop system is an extremely easy system for machine shops to learn to use. Powder is loaded into the printer, and the printer autonomously lays down 50 to 100 micron layers of metal powder and prints batches of parts. The customer can load as many different parts as they would like into that batch, and it does not change the time. The printer then ejects that batch of parts, which can move on to the next station, and the printer can begin another batch of parts. The next step in the shop system is the depowder station. Now, the shop system is a batch process, which means a batch of parts can be printed, and then that batch can be moved on to the depowder station, so another batch can then be printed at the same time. The depowder station is a fully integrated depowdering station where parts can be excavated from the powder, and that powder can be fully recovered in the integrated recovery system. Those parts, once excavated, can be placed directly into the desktop metal furnace for full sintering. Sintering technology has evolved over the years to be huge furnaces that cost hundreds of thousands of dollars and take up entire rooms like this. But what we've been able to do here at Desktop Metal is shrink down that same technology into a small furnace that is vacuum capable, partial pressure capable, and can roll through a door. And the shop system is designed to scale manufacturing from small scale to medium scale to enhance a machine shop, whether it's an external machine shop or an internal machine shop, with 3D printing capability.
All right, so this was a really, really good explanation of the binder jetting process. So it is easy to use. It is specifically meant for machine shops. It got a great form factor. You can put it in any small space you have in your machine shop, so absolutely great product. If we talk about mass production of part, there is even one more thing that we can talk about. It is the production system, and it is when you have to print millions of parts a year. This is where the production system comes in. The most affordable one, though, is the desktop metal fiber solution. So as I mentioned earlier, carbon fiber is a really, really dense material. You can print parts that are really, really stiff. And not just prototyping, but also some small batches you can print with these printers. So it's a really great product as well. So being a machinist, I would ask a specific question to myself. What about surface quality? What about tight tolerances? So let's use this part as an example part. And for example, we have your precise hole that obviously cannot be printed. We have a really tight tolerance in the pocket depths. Maybe we have a special surface quality, so you have to do a finish cut on it, or a special sealing groove that needs to be machined. So what happens then? Well, it's easy for us. We are going to add one crucial thing to this workflow we have seen earlier. And of course, it is machining. And as you all know, we are the experts in machining, and we are putting all the knowledge we have into this workflow, and this is what we call SolidCAM additive manufacturing. Because talking about all the customers we have worldwide, I mean, we're talking about 23,300 seats. We have 62,000 educational seats out there. So there is a lot of potential out there, because all the customers today, they have to get in touch with additive manufacturing, because in the future, if a machine shop does not know how to print parts, they can't be competitive anymore. So we have to help our customers that are obviously directly placed inside these important markets that I have shown at the start of this presentation. So we know the customers, and they already know us. They know we are not just selling a product, we are also offering the best possible support. And we are going to help them, our customers, to transform to the future in additive manufacturing. So we always call ourselves the solid platform for manufacturing. And I will put another thing in it now, which is called SolidCAM Additive. And I think it's the perfect combination for our solid platform for manufacturing. Talking about numbers, the 3D printing global forecast is really interesting. Until the year 2026, we estimate a market size of $35 billion US. And you know, as I mentioned earlier, our customers need to invest in 3D printers, or let's say in additive manufacturing in the future, so we have to help them making this transition. Talking about different markets, the compound annual growth rate in different countries is really interesting. For example, I'm from Germany, we have a 22% of annual growth rate, and you know, comparing it to Asia, of course, there's a little bit more potential there. And also in the US, we have about 20% of growth rate yearly, which is really interesting. So I want to ask you this one question one more time. Do you really think that additive manufacturing is going to replace CNC machining? Obviously, no. It completes it. Summary, of course. So we are going to act as a reseller of desktop metal products starting actually now. We are going to not just sell them, we are going to offer solutions to our customers, because we always say we're not just selling products, we also give the best possible support with the best possible team out there. We want to close the gap between additive manufacturing and CNC machining. And of course, we're doing all the necessary stuff that is, coming with it. We're doing installations, we do maintenance, we do everything that needs that our customers can use those desktop metal printers in a productive environment. So I really would say that SolidCAM Additive is the best solution for additive manufacturing, especially for customers in our CNC machine shops. We are going to start in Germany, obviously then we are going to transfer to the US, then in India, and at the end in Israel. And of course, there will be a lot of more countries in the future. So at the end, I want to end with one of my favorite sentences. It's success is best when it's shared. So let's share the success we see in additive manufacturing with our existing customers, and let's transform the machining world into the future together. Thank you very much.